Good morning, everyone. I hope you all are doing well. It's a rainy day out here today. Nice day for doing some math. We're gonna spend some time talking about vectors this morning and try to give you guys a better understanding of how exactly it is that vectors work. So, the first thing that we're going to do today is really discuss what a vector is. We're going to go through some definitions involved in vectors, get people to understand all the different terminology that we use with vectors, and then get you starting to think about what happens when we add two vectors together. So the first thing we're going to do is talk about what exactly a vector is. A vector is something that has both magnitude and direction, as stated by the villain Vector from The Incredibles. You need magnitude and direction. Oh yeah. So it's not enough for me to say that Megan runs 3 miles. This is not a vector. If I know that Megan runs 3 miles, I know what the magnitude of her run is, but I do not know what the direction of her run is. Megan runs 3 miles east is now a vector. I know that Megan started here and she went 3 miles in this direction. Now, if alternatively I say that Sarah runs 3 miles north, this is a vector that has the same magnitude but a different direction, because Sarah is moving 3 miles in this direction. So these would not be said to be equivalent vectors. They both have the same magnitude, but they have a different direction. I could also have somebody running west, which would be sort of the opposite of Megan's run. They would be starting here and ending here. If they still go 3 miles, even though the line would look the same, you'd have a different initial point than you would in Megan's situation. The initial point of a vector is where your vector is starting. Your terminal point is where the vector is ending. Now, for two vectors to be equivalent, you don't have to have the same starting position, you just need to have the same magnitude and direction. So if I have Megan running 3 miles east from Kalamazoo, Michigan, and I have John also running 3 miles east, but he's in Ann Arbor, Michigan, these two vectors are going to be equivalent even though they're starting in different positions. So these two people are running the same distance in the same direction, even though they're starting in different places. And we would say that those vectors are equivalent. If we wanted to look at this in terms of, say, actual points, we could say that we had vector v, which often in textbooks, you'll see it just written as a bold V. When we write it with our hands, you'll see that we draw a little line over it that represents that we're dealing with a vector. So vector V could be going from the point 0, 0 to the point 3, 2. And we could have vector W, which goes from the point 1, 2 to the point 4, 4. And the question could be asked, are these two vectors equivalent? Well, if vector v goes from 0, 0 to 3, 2 on our basical coordinate plane guy, we would have a point that's starting at 0, 0, and it's going to 3, 2. This would be our vector v, going from my initial point to my terminal point. And I could have another vector w, which starts at the point 1, 2, and it goes to the point 4, 4. you notice that these vectors look the same. They're going in the same direction and they have the same magnitude, in which case these vectors are equivalent. Now, if I had a vector r, and I said that RR went from the point 4, 4 to the point 1, 2, I would now be starting at this point and I'd be going in this direction. Even though the two vectors would have the same magnitude, they would be going in different directions. So vector r would not be equivalent to vector w or to vector v. If I want to find the magnitude of a vector, really all I'm doing is finding the length of this line. I can use the distance formula or the Pythagorean theorem. For all of these vectors, I'd take the difference in x, which is 3. I'd take the difference in y, which is 2. And 3 squared plus 2 squared is going to equal 13. So the magnitude of this vector is going to be the square root of 13. If I want to note that I'm talking about the magnitude of a vector, I could say that that is equal to, something that looks like that. It looks like absolute value brackets, and that's telling me that this is the length of my vector. So we've talked about what a vector is. We've talked about an initial point versus a terminal point. We've talked about what makes vectors equivalent, and we've talked about how we find their magnitude. The last thing that we're going to talk about is what's called the resultant. And I'm going to go through some relatively basic examples here that eventually will get slightly more complicated. So let's start with a relatively simple situation. Let's say that you and I are feeling sort of bored and we decide to take out 2 straws and blow on a piece of dust that's sitting on the table. I decide that I am going to blow so that my movement is going this way, and I'm able to blow dust so that it moves at 80 miles per hour because I've got pretty strong lungs. And you decide that you're going to blow this dust so that it goes 100 miles per hour in the northward direction. If we both blow at the same time, the dust is going to travel in this direction. This is called the resultant. This is the sum of our 2 vectors. Now, the same thing would happen if I blew on the dust for some amount of time and then you blew on the dust for the exact same amount of time. So I could take one piece and then the other piece, or I could have them both act at the same time. Either way, the piece of dust is going to end up out here, and this is what is called the resultant. So let's call this vector m for me, and let's call this vector y for you. If I wanted to know what I get from taking vector m plus vector y, well, that's going to be this thing. And I could say, want to find out what the magnitude of this vector is. Well, if this is 80 miles per hour and this is 100 miles per hour, then if I want the magnitude of this resultant vector, which I'll call r, the magnitude of r would be equal to the square root of 80 squared plus 100 squared, because that is just the hypotenuse of this right triangle. So this is going to be 6,400. This is going to be 10,000. So I'd have the square root of 16,400 would be the magnitude of this vector. I could also ask, what is the angle that the resultant makes with the weaker force, for example? Well, if this is the resultant, this is the weaker force, and the angle made by the resultant and the weaker force is going to be this angle right here. Well, since I was blowing east and you were blowing north, these form a right angle, which is great. We love right angles because it means that we can use right angle trigonometry. If we want to know this angle, we could just say that the tangent of theta is equal to 100 over 80, because remember, this is 100. It doesn't matter whether you blow here or you blow here. The object is still going to end up in this position. So I would take tangent of theta equals 100 over 80, which means that theta would equal whatever the inverse tangent of 100 over 80 is. And I can use that to find out what my angle is. Now, this is a relatively simple example because we happen to both be blowing at right angles to one another, but that's not always going to be the situation. Let's say that instead we decide to blow at a 40-degree angle to one another. So let's say that I blow, and we'll call this vector M, and I blow with a force of 100 miles. Actually, let's stick with 80. We're going to keep the same force. So I blow at 80 miles per hour, and you decide to blow at 100 miles per hour at a 40-degree angle to what I'm blowing at. Now, if this is what happens, I could position these two things in any direction. I've got this thing and I've got this thing, and I know that this is 40 degrees and this is 80 and this is 100. But if I can position these any way that I like, what I find easiest to do is to position them on an XY axis. And I'm going to say that I blow exactly on the x-axis so that my vector is going in this direction at 80 miles per hour. And that means that you're going to blow in this direction, where this is 40 degrees, at 100 miles per hour. Now, if I blow on the dust this way and you blow on the dust this way, I want you to think for a moment about where exactly the dust is going to end up going. The dust isn't going to go off in this direction somewhere. The dust is going to go somewhere in between our two forces. The dust is going to end up in this position over here. And this, again, is called the resultant. Now, again, we could either have the two of us blow at the same time and shoot it off in this direction, or I could blow and then you could blow. Or vice versa. You could blow and then I could blow. Either way, the object is going to end up over here, and this is what we call the resultant. And in this case, if I want to find out what the magnitude of this vector is, I can no longer use the distance formula because this is not a right triangle. But it is still a triangle, which means that I can use my rules for non-right triangles. If this is 80 and this is 100, and I'm interested in finding the magnitude of R, that is a side that is opposite this angle. So the question becomes, what is the measure of this angle? And I want everybody to think, based on what we know right now, if this is 40 degrees, what's the measure of this angle right here? Since this line is parallel to this line right here is what we call a transversal, which means that this angle and this angle are corresponding angles. So this little angle right here is also 40 degrees, which makes this angle 140 degrees. So now we have a side angle side triangle, and we can use the law of cosines. So the law of cosines would say that r squared is equal to 80 squared plus 100 squared minus 2 times 80 times 100 multiplied by the cosine of the angle opposite r, which is 140 degrees. I can use my calculator to find out what that's going to be. I'm in degree, that's good. So I'm going to take 80 squared plus 100 squared minus 2 times 80 times 100 times the cosine of 140 degrees. And that equals my value squared, which means that I want to take the square root of my answer. And that means that overall this piece of dust is going to be moving at 149.187 miles per hour, assuming, of course, that we don't take into account air resistance and stuff like that. So we would say that the magnitude of R is equal to, oops, I need my little vector sign there, is equal to 149.187 miles per hour. And if I wanted to find the angle that this vector makes with, let's say, the weaker of the two forces, we'll say 80, that's going to be this angle right here. So if I want to find out what that angle is, well, I now know the three sides in a triangle, which means that I can use the law of cosines again. This angle is opposite 100, which means that I would set this up as 100 squared equals 80 squared plus 149.187 squared minus 2 times 80 times 149, multiplied by 0.187 multiplied by the cosine of, we'll call it theta. These are adding on to one another, whereas these are all multiplying by the cosine of theta. So I would need to subtract these two values. I'd have 100 squared minus 80 squared minus 149.187 squared. And that's going to equal negative 2 times 80 times 149.187 multiplied by the cosine of theta. Well, if I want to get rid of all of this, I would have to divide by these values that are multiplying by the cosine of theta. So I would divide by negative 2 times 80 times 149.187, and that equals the cosine of theta. Now, even once you get to this point, this is where a lot of people will make a mistake using the law of cosines with their calculators, because they're going to have errors of input. I prefer to put this all in as one statement, but if you put this all in as one statement into your calculator, you need to have parentheses here, and you need to have parentheses here, so that your calculator properly follows the order that you're asking it to do. So within our calculator, we would have parentheses 100 squared minus 80 squared minus, I'm just going to call this my answer, squared, which means that I no longer have a rounding error, divided by negative 2 times 80 multiplied by my answer. And that number is what is the cosine of theta. So I'd need to take the inverse cosine of that value to get my final angle, which is going to be 38.593 degrees. So theta equals 38.593 degrees. I hope that that gives you at least some idea of how vectors work and makes you a little bit more comfortable with working with some of the stuff that you see in the problems that I've assigned. I hope everybody is doing well. I hope you're staying home and staying safe. Keep on doing what you do, getting your work done. I'm really, really proud of how much effort you guys are putting forth. It's clear to me how much work you guys are really trying to get done. So let me know if you have questions about this, and I'll be happy to help you as much as I can. Continue to be well. I'm thinking of you all. Talk to you soon. Bye.